Happy Friday, welcome. Let me go ahead and pop that open. So I'm going to do this rather quickly here. Pull up VS Code or Jupyter Notebook or Jupyter Notebook on VS Code, wherever you want to code up. All right, I'm going to go ahead and quickly import pandas SPD for most of those common functions. And then if I need NumPy, I'll import it later. We'll see. I'm just going to go ahead and run the cell. Let's use a real data set to solve this problem because plotting histograms is going to be a very important tool for you to master in data science when you have to discuss distributions of data sets to, especially when it comes to price, if you're trying to predict price to the stakeholders. You're going to want to know how that distribution is. Is it long-tailed? Is it normally distributed Gaussian? What is it? Is gamma, like what is, if the mean's greater than the median, it's going to be a right skew, and then otherwise it's a left skew, and so on and so forth. If you ever need to practice something in Python, what I want you to do is know that in scikit-learn, they have several publicly available data sets that you can immediately import. So if you go to from sklearn, import data sets, you will load that as a library. And then from there, a very common one is iris. You can assign it immediately to the iris variable. And the cool thing about VS Code is when you start typing, it tells you what you can fill in. I don't think you have that with Jupyter notebooks traditionally. You can just do load iris like this. And so notice immediately when you hover over this, or as you start typing that, it tells you what this is. Well, it just did a second ago. And so from there, I'm going to go ahead and assign my X's and Y's. And so X is going to be my iris.data. And then if I have a target, it'll be iris.target. That's for later if you want to build a predictive model or something like that. But right now, let's see what happens if we just print out the variable iris, and it's just a NumPy array. If we print out X, that's still just a NumPy array. So one of the things that we can do is convert this NumPy array into a pandas data frame. And so if we want to convert this to a data frame, you do start with always pd.dataframe. And your data is iris.data. And then your columns are iris.feature names, like so. And then I forgot an opening parentheses. So here we go. So if we run this below or in the same cell, we should have the data frame for iris. So this is how you can load any data set from scikit-learn. If you read the documentation, they have several. You can practice with the wine data set, some very popular publicly available data sets. But if I wanted to, let's say I wanted to get the histogram of the petal length, which would be like column A, B, C, or the third column. If you take this data frame, iris, 10 iris is your DF, that's your data frame. And then you put your petal length column inside, and then you just call it as a column inside the brackets. And then you just call the .hist function by itself. It's an open function, nothing goes inside yet, unless you wanted to. That by itself will just give you the histogram for the distribution of that column. But the cool thing about the .hist function is you can remove the grid. So you could say grid equals false, and then you have that. You could also put edges around those bars. So you would go edge color equals black. Just makes it a lot neater. And then, of course, as always, what we want you to get in the habit of, this is going to be very important, you always want to label your title and axes. We can't stress this enough. So we give this a plt.title histogram of petal length centimeters, something like that. And then, of course, we don't have PLT. Why is that? Because we need to import. And we'll do the import over here, actually. Import mat matplotlib. PLT comes from matplotlib dot pyplot as PLT. And so then when you run that, and let's run this again up top and then run this, it is this. And so we want to be very precise with our column names. Like so. And there we go. So we have the title histogram of petal length, centimeters. And then similarly, if you want to label, we're not going to go through the motions here right now, but if you want to label your x-axis, you go plt.x label. Same thing for y label. Always label your titles and your axes. And so, yeah, and then you can also specify inside the hist function with after another comma, the bin sizes. So right now the default is 10 bins. You could say, so okay, right now it's 10, so that's not going to change anything. Let me comment this out. I don't want to label it right now. But if you use, let's say 100, then this is more like if you have percentiles, right? And if you're looking at deciles and you want to bin your deciles, you can go 10. So it's up to you how wide or narrow you want your bins to be. And if you want to get rid of this thing up top, this weird looking matplotlib text, this artifact, you go plt.show at the end, like so. And that cleans it up. And of course, don't forget to label your graphs. But yeah, that's how you would find the distribution of the continuous variable in Python. So yeah, we wanted to try something different this week, and we want to get you to understand like how to set up a sample space and work with that. And because this week really does focus on probabilities. So yeah, right. We have a little bit of time here. So let's say we want to create a sample space for 5 random guesses of something, right? You know, let's make it 5 for now, and then let's say everyone here is a video game aficionado, right? Which I don't think is necessarily the case. I used to be, I'm not anymore. I care less about video games. Maybe I'll change, we'll see. But let's say we're all tasked with matching 5 different game controllers, and I'm just kind of making this up as I go, game controllers to the consoles that they belong to. And so each controller would represent a unique console. And then let's say we need to create a sample space for, I'm going to comment this out, create a sample space for the 5 guesses, right? And so if we're going to use random guessing, we need to figure out what the probability is for the probability of correctly matching all 5 controllers to their consoles, something like that. And so let's see if I can do it like this first. What I want to show you is the following. If we were to, let's say, we want to determine the number. Can everyone see that? Number of possible outcomes. It's just a little bit of theory behind it. So we have like the total number of arrangements. These are permutations, right? That term is going to come up a lot. And so you want to calculate those permutations by multiplying the number of choices for each of these controllers. So we start with 5, we go down 4 times 3 times 2 times 1 is equal to, that's your 5 factorial, or that gives you 120 when you calculate that out. That's something I remember. It's very common. 5 factorial, so 120. So this means that you have 5 choices, 5, 4, 3, 2, 1. And that's for the first controller. You have 4 choices for the second controller, and so on and so forth, all the way down to the last controller. So to determine the probability of the correct guess, there's really only one way to match all controllers correctly out of those 120. possible permutations. So you would do to calculate probability, or P, is take 1 over 120. And so let's pull up our calculators or Excel and just go 1 divided by 120, and that's about 0.008%, or roughly 0.0083, something like that. So basically roughly 0.83% is the chance that you have of successfully matching all controllers to their respective consoles when you're guessing at random. So let's go back to our code rather quickly. And so let's write this out using Python. The way I would do this, there's several ways. And I kind of want you to know that in Python, there's not one specific one-size-fits-all solution to doing something. And so the way that I would do this myself is, there's one library that I like to use. It's called itertools. And then from there, you can import permutations. So if you were to do a Google search and you're working with permutations, so a nice library to use for that would be itertools, and then you pick up permutations from that. This is one way to do it since we're working with consoles. Notice I'm putting all these into separate strings, and I'm making a list of these strings. So you have to, every value is going to be nested in a pair of either single quotes or double. It doesn't really matter. The only time it matters is if your string has like an apostrophe. It's going to confuse that single quote with the apostrophe. So in that case, you want to standardize everything and make it into a regular pair of double quotes. But I'll fill it in. They'll say, well, this is old. I don't want to age myself here, but Sega, and then Atari. I never messed with Atari, but that's 1, 2, 3, 4, 5. That's one way to do it. And then from there, we can just create a sample space. So we assigned it to a new variable sample space, and we take this as a list. And in Python, list is a function of, this is where we use that permutations that we just imported of what we just assigned here, the consoles. So that's what that permutations is for. So it'll do the heavy lifting for you. And then from there, let's see what happens when I run that. Okay, number one, good news, it worked. But what did it do? Let's see. You can print it, or you can just call the variable. Same thing, sample space. And when you do that, it gives you all the permutations of X, all these different permutations. There should be like 120 of them. Let's see. If you go length, len, of sample space, it returns 120. And that's exactly right. But if I want to print, let's use a print statement here. So if you want to print this sample space, you can use an F string. The F string comes in handy when you want to combine strings and variables. So you can say sample space would be the string, and anything inside that, in front of that F, or behind that F rather, goes like this. You still keep that quote, everything inside the quote. And then what you do is you open up a pair of curly braces, and then you put in the variable sample space. So when you print that, this should give you the sample space this way. But if you want to also go and then print the, let's say the total number of outcomes, you can go the length, what we did earlier, of the sample space. Take out that B and put that in here inside the curly brackets, whatever they're called. And I just completely goofed. So I'm going to take this. This needs to go inside the print function, and then we run that. So we have a bit of a mistake because I have an extra curly brace over here. And so this really is, I think I'm missing something here. It's the length of the sample space, like that. And it's inside the function. So I want to do it this way. My gosh. And then, you know what? Oh, I forgot the F in front of it. My bad. So we open this up like this, and then we have 120. There we go. So that's what an F string does. It combines the variables and the strings like that. So that's pretty much it. Oh, and then we also want to get the probability, right? So that would be, you could do it just this way. 1 over the length of the sample space.